A warm good afternoon to all. I'm Karthik, Assistant Professor, Mechanical Engineering Department. In continuation with the previous video which we seen about humor role, and this lecture series is about phase diagram. First, after the humor rule, I like to share a few notes on copper nickel phase diagram. The reason for choosing this copper nickel phase diagram is that this copper nickel phase diagram is very simple phase diagram which has a liquidous line, solidus line, and liquid and solid formations. And the next major thing to select this copper nickel phase diagram is that this copper nickel phase diagram, the copper and nickel has 100% solubility for each other. If we add 100 kilos of copper and 100 kilos of nickel, it will mix together, and this copper and nickel perfectly follows the humor theory. Right. So this in this copper nickel phase diagram illustrates the phases and the phase transformation that occurs in the function of temperature and composition when copper and nickels are mixed together. The copper nickel phase diagram typically consists of various regions representing different phases such as solid solutions, intermetallic compounds, and eutectic reactions. Here a simplified description of copper nickel phase diagram shows that first one is pure element region. At low temperatures, both copper and nickel exist respective pure metal phases as alpha copper and alpha nickel. Solid solution region. The solid solution region, as the concentration of nickel increases in copper, or it happens vice versa, a single phase solid solution forms. This region is often referred as the alpha phase region. Here you can see a complete mixture of both copper and nickel. The third one is intermediate phase. There are several intermediate phases that can be formed in copper and nickel system. Includes Cu3Ni, which is the gamma phase, and Cuna, which is delta phase. So these phases often occur at specific compositions and temperatures. The fourth one is eutectic reaction. The copper and nickel exhibits a eutectic reaction where at the specific composition and temperature a eutectic mixture of alpha copper and alpha nickel forms. This eutectic point represents the lowest melting point of a mixture of copper and nickel. So the phase diagrams may also include various lines indicating phase boundaries such as solidus line, which is limiting the solid solubility, liquidus line, which limits the liquid phase stability, and it is important to note that the phase diagrams may depend on pressure. So the typical phase diagrams are drawn for the atmospheric pressure. So additionally, the exact position of phase boundaries and other phases may influenced by the impurities of processing conditions. So here it is recommended to refer a specific phase diagram charted at a certain temperature and pressure. In this copper nickel phase diagram, you can see as all phase diagrams, it is drawn based on the atmospheric pressure, but not on high pressures or any specific low pressures. So any phase diagrams will follow will have its own invariant reactions, single phases, double phases, and liquidus and solidus lines, where you can see above liquidus line is completely liquid, and below solidus line it is completely solid, and in between liquidus and solidus line you can see a semi-solid state where you can have a mixture of both elements. And we can in this from this phase diagrams we can easily say that for a particular temperature for a particular percentage of any element, you can say what component is formed or what phase it formed, either it's a liquid, solid, etc. So in this condition, we can say this copper nickel phase diagram helps to see, or it looks like graph where at a particular point we can say what type of coordinates or what type of coordinates I can in infer it can say that what type of solution or what type of solubility or what type of solid solution is formed. Okay, that's all for today. Thank you and have a great day.